In this video, we'll discuss the characteristics of square root, cube root functions. We're going to be analyzing the graphs of those. So we're given r of x equals the square root of x minus 1 minus 4. We know that graph is going to go right 1 and down 4. We know the stretch is by a factor of 2 because the 2 in front. So our next point would be 2 above, and we can sketch our graph. All right, looking at our graph, we don't know the x-intercept exactly, so we would set our equation equal to 0 and solve for x. Add 4 to both sides. We get 2 times the square root of x minus 1 equals 4. Divide both sides by 2. We get the square root of x minus 1 equals 2. Square both sides. X minus 1 equals 4. Add 1 to both sides. So x equals 5 would be our x-intercept, and we find that by setting y equal to 0. To find the y-intercept, we would set x equal to 0. So if we plug in 0 right here, we get the square root of 0 minus 1, which is the square root of negative 1, which is not possible in a set of real numbers. So we have no y-intercept. If you were to type that in a calculator, you would get a domain error. Our domain for our graph, our x value, we go from 1 left to right, domains left to right, to infinity. 1's included, so 1 gets a bracket. Our range goes up and down, so how far down does our graph go? That point right there is where our graph stops, and the y value there is negative 4. So we go from negative 4 to infinity. Our end behavior as x goes to negative infinity. This doesn't exist, so it does not exist. The reason it doesn't exist is because our graph stops right there. And if we're talking about as x goes to negative infinity, that's just not possible. So as x goes to positive infinity, so as we go further to the right, the first statement is talking about the left side of the graph. The second statement is talking about the right side of the graph. So as we go further to the right, our graph's clearly growing up to infinity. All right, negative x plus 2 plus 1. This is going to go left 2 and up 1. It's reflected, no stretch or shrink, so we get something that looks like that. X-intercept is pretty obvious looking at the graph, negative 1, 0, so I don't actually need to solve for that. We're going to plug in 0 for the y-intercept, so we're going to put 0 right there for the x value. We're going to type that in our calculator. Negative the square root of 0 plus 2, and then outside the square root, we're going to put a plus 1, and we get negative 0.4 if we round to 1 decimal place. The domain, we go left to negative 2, and we go right forever. The range, our graph's reflected this time, so it goes down forever, and it only goes up to that point. The y value of that point right there is positive 1. The end behavior, again, as we go to the left, we can't go to a negative infinity because our graph doesn't go to negative infinity, so that does not exist. If we go to the right, our graph's clearly decreasing, so the y values would be going down to negative infinity. All right, we have 1/2 times the cube root of x minus 4, so we're going to go right 4, and minus 1 means we're going to go down 1. Shrink by a factor of 1/2, so the next points would be half away from the points that we currently have on the graph. All right, to find the x-intercept, we set our equation equal to 0, and we go through that and solve for x. So we get 1/2 times the cube root of x minus 4 equals 1. To get rid of the 1/2, we can divide by 1/2 or multiply by its reciprocal, 2 over 1. So we get the cube root of x minus 4 is equal to 1 times 2 is 2. To get rid of the cube root, we would raise both sides to the third power. So we get x minus 4 is equal to 2 to the third, which is 8. And then we can add 4 to both sides. So x equals 12. So our x-intercept would be 12, 0. Y-intercept, we're going to plug in 0 for the x value here. So we get, let's see what we get. We get 1 over 2. Maybe 1 over 2 times the cube root of 0 minus 4, and then outside a minus 1. So we get 0, negative 1.79 would be our y-intercept. Our domain for cube root functions is a little different than square root functions. Our graph doesn't stop. It keeps going to the left forever. And it doesn't stop on the right side either, so it keeps going to the right forever. So negative infinity to infinity, those always get parentheses. The range, this graph, even though it looks like it's only going to the left, it does continue to go down very slowly to negative infinity. The right side's going to go up to positive infinity. The left side of the graph this time, we can talk about the end behavior because it does continue to go to the left. It's going down on the left side. It's going up on the right side, so positive infinity on the right side. The only difference, this graph is reflected. We would find the x and y intercepts the same way. The domain and range would be exactly the same. But the end behavior this time would be the opposite because if it's reflected, the left side of the graph is going to go up and the right side of the graph would go down.